Hello, this is section 9.3, solving quadratic equations using the quadratic formula. Part 1, quadratic formula. Quadratic formula. The solutions to a quadratic equation of the form ax squared plus bx plus c equals 0, where a does not equal 0, are given by the formula x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. To use the quadratic formula to solve a quadratic equation, we substitute the values of a, b, and c into the formula and simplify the expression. Example 1. Solve by using the quadratic formula. So I see that a is equal to 2, b is equal to 9, and c is equal to negative 5. So our solutions are x equals negative 9 plus or minus the square root 9 squared, which is 81, minus 4 times a times c, which is negative 40, all over 2 times a, which is 4. So we get negative 9 plus or minus the square root of 81 minus negative 40, so that's plus 40, so 121, all over 4, which equals negative 9 plus or minus 11 over 4, which equals 3 over 4, or negative 20 over 4. And the negative 20 over 4 is negative 5. Part B, x squared minus 6x equals negative 5. The quadratic formula only works if the equation is set equal to 0, very similar to factoring. So the first thing we have to do is add a 5 to both sides. We get x squared minus 6x plus 5 equal to 0. And then a is equal to 1, b is equal to negative 6, c is equal to 5. And then we get x is equal to negative b, so 6 plus or minus b squared, which is 36, minus 4 times a times c, which is 20, all over 2 times a, which is 2. So we get 6 plus or minus the square root of 16 over 2, which is 6 plus or minus 4 over 2, which is 10 over 2, and 2 over 2, which is 5 and 1. Part C, 2x squared plus 10x plus 11 equals 0. So a is equal to 2, b is equal to 10, and c is equal to 11. So we get x is equal to negative b, which is negative 10, plus or minus the square root of b squared, which is 100, minus 4 times a times c, which is 88, all over 2 times a, which is 4. Go through and simplify this. We get negative 10 plus or minus the square root of 12, all over 4. Now, this time I can't take the square root of 12, but I can simplify it because 12 is 4 times 3. And then the square root of 4 is 2, so we get negative 10 plus or minus 2 square root of 3 all over 4. And now all three of the terms are even, so I can reduce by 2 to get negative 5 plus or minus 1 square root of 3 all over 2 as our final answer. Part D. A is equal to 3, B is equal to 2, and C is equal to 9. So we get x is equal to negative b, so negative 2, plus or minus the square root of b squared, which is 4, minus 4 times a times c, which is 108, all over 2 times a, which is 6. So we get negative 2 plus or minus the square root of negative 104, all over 6. And again, 104 is not a perfect square, but I can simplify it. The first thing I'm going to do is, because it's negative, is take an I out. And then 104. 4 times 26. Yep. All over 6. And then that becomes negative 2 plus or minus 2i square root of 26 all over 6. And reduced by 2 again, we get negative 1 plus or minus 1i square root of 26 all over 3. And that is the answer to part D. Now on to part E. So first thing with part E is I need to get it in standard form. So I'm going to distribute the 4x to get 4x squared minus 20x is equal to negative 25. And then I need to add 25 to both sides. So we get 4x squared minus 20x plus 25 is equal to 0. So A is equal to 4, B is equal to negative 20, and C is equal to 25. So X is equal to negative B, which is 20, plus or minus the square root of B squared, which is 400, minus 4 times A times C, which is also 400, all over 2 times A, which is 8, which gives us 20 over 8, because the 400 minus 400 is 0, so it just cancels out, and reduce our answer by 4, we get 5 over 2. So our answer is 5/2. Now the nice thing about the quadratic formula is when you have fractions, you can clear the denominators to get rid of them. So for this one, instead of getting in standard form first, I'm going to clear the denominators. So the LCD, which I'm hoping you're getting good at finding that, is equal to 6. So I'm going to multiply both sides of the equation by 6. 6 times a half is 3, so 3u squared. 6 times 2/3 is 4, so plus 4u. And 1/3 times 6 is 2. Now there's no more fractions. I can get 0 on one side. And we get 3u squared plus 4u minus 2 is equal to 0. So A is equal to 3, B is equal to 4, and C is equal to negative 2. So X is equal to negative B, so negative 4, plus or minus the square root of B squared, 16, minus 4 times A times C, which is negative 24, all over 2 times A, which is 6. So we get negative 4 plus or minus the square root of 40 all over 6, which is negative 4 plus or minus the square root of 4 times 10 all over 6, which is negative 4 plus or minus 2 square root of 10 all over 6, which is negative 2 plus or minus 1 square root of 10 all over 3. Part 2. Predict the number of solutions. The expression under the radical of the quadratic formula makes it easy for us to determine the number and types of solutions a quadratic equation has. This expression is called the discriminant, b squared minus 4ac. When the discriminant is positive, the quadratic equation has 2 real solutions. When the discriminant is 0, the quadratic equation has 1 real solution. And when the discriminant is negative, the quadratic equation has 2 complex solutions or 0 real solutions as well. Example 2. Determine the number of real solutions to each quadratic equation. So I'm just need to calculate the discriminant. So A is 3, B is 7, and C is negative 9 for the first part. So B squared is 49 minus 4 times A times C. No. 4 times A times C, which is negative 108. That gives us 157, which is positive. Another way to say positive is greater than 0. So this has two real solutions. Part B. A is 5, B is 6, C is negative 2. So B squared is 36, minus 4 times A times C is negative 40. So we get 76. So two real solutions. And then part C. A is 1, B is 7, and C is negative 13. So B squared is 49, minus 4 times A times C, which is negative 52, which gives us 101. So there's two real solutions. But just keep in mind, if these numbers are ever equal to 0 or less than 0, you get the above definition to determine the number of real solutions. And that is it for section 9.3.